Prognosis is a unique diagnostic system for differential pressure meters, developed by Swinton Technology and DP Diagnostics and launched in 2010. Prior to this system, the operator had no way of guaranteeing meter performance other than due diligence and adherence to industry standard practice. Taking the orifice meter as an example, operators must inspect the plate and the meter run at regular intervals, which can be an expensive and time-consuming process, not to mention the safety risks attached. If there is any damage or wear to the meter, it must be replaced with a new one. The secondary instrumentation is tested and calibrated, and the flow computer is also checked for any errors in calculations or constant values. This standard practice has not altered in the oil and gas industry for over 100 years, until now. Prognosis is a revolutionary system which can vastly reduce maintenance costs, as well as ensure meter accuracy. Here we see a real orifice meter run set up to demonstrate the Prognosis system. The essential components to any DP meter are the primary element causing a drop in fluid pressure and a DP transmitter measuring that drop in pressure, which is used to predict the rate of flow through the meter. However, with an additional pressure tapping downstream of the meter, we can read not just the traditional meter DP, but also the recovered DP and the permanent pressure loss. Using the 3 DP readings, the pressure field through the meter is monitored. The 3 DPs are compared in multiple ways to provide assurance of correct meter operation and to also identify potential malfunctions in the meter system. A simple live diagnostic screen is shown in the control room. The diagnostic plot comprises 4 points around an origin and a box. The concept is very simple. If the points remain in the box, this ensures good flow measurement. If any points are outside of the box, the integrity of the meter is under question. We'll now see some live demonstrations using this diagnostic-ready meter connected to a Prognosis user interface. The position of the plate is crucial for accurate measurement, and the flat, sharp edge must face upstream. With the plate positioned correctly, and with accurate process data and meter geometry, we would expect the meter to be performing in compliance with the agreed standards to within allowable uncertainties. The diagnostic response reassures us of this. All of the points are inside the box and no alarm is raised. We'll now see how Prognosis responds to an obstruction in the meter, simulated here by a piece of tape across the orifice hole. We see straight away that the points move outside the box, indicating a malfunction in the meter system. In addition, the pattern of the points tells us that there is no issue with the DP measurements, but that there is an issue with the meter body itself. And what's more, this pattern is indicating that the meter is overreading. One of the reasons for this would be an obstruction of the orifice hole. The second example sees us unbalancing one of the DP transmitters, causing a shift in the instrument reading. So this is simulating a drifting DP cell or a badly calibrated DP cell. Again, a malfunction is indicated straight away, only this time the pattern of the results tells us that there is a definite issue with the DP readings. What's more, the pattern tells us further which DP is in error. In this case, it is the traditional meter DP, which will be causing a significant bias in the meter's flow rate prediction. Another example. It is a commonly reported occurrence that keypad data can be wrongly entered into a measurement system's flow computer due to manual error. In this case, the orifice diameter is entered as 69.5 mm instead of 65.9 mm, a typical finger trouble error. These values in the flow computer are picked up by Prognosis, which is now comparing the physical reality with a false meter baseline. Not unsurprisingly, the operator is alerted to a malfunction by the diagnostic software. Again, no instrumentation issue is reported, which points us towards an issue with the meter itself. In this case, a wrong geometry setting. Other examples of problems which produce an alarm with Prognosis are backwards installed plate, damaged or buckled orifice plate, a worn meter, contamination and liquid carryover, a leaking transmitter manifold, blocked impulse line or saturated transmitter. The pattern produced by the diagnostic response can give critical information on the actual error with the meter system. saving time and money on unnecessary investigation and maintenance work. As well as the main user interface, Prognosis can hand off results and alarm statuses to a third-party system. Prognosis can also email a specified user when an alarm is raised. This way the operator is alerted to issues remotely, even from an unmanned platform or other remote locations. Periodic reports on the meter's performance can also be emailed, providing the operator with auditable evidence of the meter's accuracy. A comprehensive user guide is supplied with the software, which provides detailed information on potential meter issues based on the diagnostic results. Major operators are already realising the benefits of the system in assuring accuracy and also identifying mismeasurements which may otherwise go undetected. Prognosis can be used as a basis for a condition-based maintenance strategy, and global regulators are encouraging this approach.